Hey everybody, this is Mr. Beckstrom, and today I want to take a look at an example from section 10.2. This is number 10, and this is working on the parabola, and I just really kind of want to go through the process of how we're going to really be doing all of these problems, what values to look for, how to solve for those values, and so on. So the first thing that we need to know is whether or not the vertex, that's kind of like the bottom of the bowl, is at the origin or if it's not at the origin. And we can clearly see here that this is not at the origin. And that means we're going to be using the formulas from page 659 in the book. If it did, if the vertex was at the origin, we'd be using the ones from page 657. They're pretty similar, but there are some differences where we need to use the vertex point. So the formula, and this is a left opening parabola. So the formula for a left opening parabola is the second one there, and it is y minus k, quantity squared is equal to negative 4a times x minus h, and that's the formula right there. So in order to kind of write the equation, we're going to need to be able to solve for h, k, and a. Now hk is real easy because hk is our vertex. So hk is the vertex, and that's kind of the center bottom of the parabola here, vertex. So in this case right here, hk is 0, negative 6. 0, negative 6. So the first thing I'm going to do is just go ahead and plug those in for my h and my k. So y minus a negative 6, that's going to end up being y plus 6. Quantity squared is equal to negative 4a times x minus h. H is 0, so that's just going to be x. Now notice here that we just have the x, the y, and the a here. And in order to complete this, remember the formula is going to have an x and a y in it, but we should have an a. So what I can do is I can use a point other than the origin, plug that in for my x and my y, and then solve for a. So they do give me a point other than the origin, and that's at negative 1, negative 5. So I'm going to replace the y here with negative 5. 6. Quantity squared is equal to negative 4a times that x that they give me, which is negative 1. Negative 1. And that's going to give me negative 5 plus 6 is 1. 1 squared is 1. So 1 is equal to, the negatives cancel out, and I'm just left with 4a. And in this case right here, a is equal to 1/4. 1/4. Now remember that a is the distance between the vertex and the directrix, and also the vertex and the focus. The directrix is always outside of the parabola, so it'll be on the other side. It'll be a kind of a vertical line here on the other side, 1/4 units to the right of this, and the focus will always be kind of in the bowl of the parabola, and it'll be that a units to the, in this case, to the left here. So now that we've got everything we need, let's go ahead and plug it into this equation right here, and then we'll simplify it. So we have y minus negative 6, so that's going to end up being y plus 6. Quantity squared is equal to negative 4 times 1/4. And that is going to be, that's 4a, and then we're going to have x minus times, I can probably write that like that, times x minus 0, because 0. All right, so kind of simplifying everything, I'm going to get y plus 6 quantity squared is equal to negative 4 divided by 4 is negative 1. So that's just going to end up being negative x. Oops, I said x, I didn't write x. X. And this here is our formula for a left opening parabola. If you wanted to put it in terms of x by itself, not negative x, you could just multiply both sides by a negative. So you can also write it like this. X is equal to negative y plus 6 quantity squared. All right, I hope this helps. It's going to be the same process regardless of which way that it opens. If you're using the normal vertex formula, that's where we have y. Oops, hold on just a moment here. That is the one where y is equal to x minus h quantity squared plus k, with the a in front there. You can also do it that way, but this is just how the book is doing it here, so I want to make sure that you know how to do it this way as well. If you have any questions, please let me know, and I hope you have a great rest of your week. Thanks.